Okay. So this section is talking about potential energy. So kinetic energy is the energy of what? Movement or motion. Potential energy is the energy of
Changing something distance from the ground.
position. Yes, changing your position. So as the figure below indicates, work must be done to lift the bowling ball from the floor to the shelf. So if you have something on the floor, you lift it up to the top shelf or to a shelf, then you are changing its position. So even though the ball has no kinetic energy, okay, once it's resting on the shelf, there is work done in lifting the ball. It's stored, that work is stored as potential energy. So remember the first law of thermodynamics, energy and matter, both in physics, we deal more with energy than chemistry, we deal more with matter. But it's the same thing. They cannot be created, they cannot be destroyed. So the kinetic energy turns into potential energy. So once that ball reaches the top of the shelf and it's just sitting there, it's no longer moving. It didn't lose kinetic energy. We didn't destroy that energy. We simply changed its form. It went from being kinetic to being potential. Okay. So the work done in lifting that ball didn't get lost. We didn't destroy it. We just changed its form. Okay. And the amount of potential energy is determined by its position, how high above the ground it is. All right. Oops. So even though energy is stored for later, we call that potential energy. It has several forms of potential energy. The one we're going to talk about right now is gravitational potential energy. So that would be, again, since we're talking about gravity, that would be its position relative to the surface of the earth. Okay, so gravitational potential energy is basically how far above the surface of the earth is it? And that determines the magnitude of that amount, that potential energy. So gravitational potential energy is going to be equal to the amount of work required to lift that object that particular height. So here is another work equation. Okay, so we have a work equation in terms of kinetic energy. That's our 1/2 mv squared minus 1/2 mv squared. Now we have a work equation in terms of gravitational potential energy. So it's mass times gravity times height. Okay. So it's the work you have to put in to lift that particular mass, whatever it is, a certain height. And the force that's imposing that motion is going to be gravity. Gravity's pulling down, you're trying to pull up. So that's why we have to include the acceleration due to gravity. Okay. The units are the same. So let's look at the example. Find the gravitational potential energy of a 65 kilogram person sitting on a diving board that is 3 meters high. Okay, so all you're going to do is plug and chug. Potential energy or gravitational potential energy is mgh. Okay, remember, work energy theorem, basically work is equal to energy, right? Same thing with potential energy. Work and potential energy are kind of interchangeable. It's the same formula, mgh. Okay, so to find the potential energy, you're going to take your mass times gravity times how high the diving board is. So 65 times 9.8 times 3. So the potential energy of that person is 1900 joules. Meaning, if they slid off the diving board, they no longer have potential energy. What kind of energy do they then have? Kinetic energy. So that 1900 joules of potential energy turns into kinetic energy. Okay. So the other type of potential energy we can have is with things like springs or rubber bands. Rubber bands and springs, they both return to their original size. So if we stretch it out and you let go of it, it goes right back to its original size after being distorted. So anything that is elastic, whether that's a rubber band or a spring or anything like that that stretches. Stretching requires work. So stretching a spring, stretching a rubber band, it all requires work. And this work gets stored in the form of potential energy. Okay. So the potential energy stored in a distorted elastic material is called the elastic potential energy. I love these vocabulary words where the definition is actually in the word. Elastic potential energy is the potential energy stored in an elastic substance. Okay. Gravitational potential energy is the potential energy stored in a substance or in something depending on its height above the earth, or so depending on gravity. So when you stretch a spring a certain distance x, there's a force exerted on it. We learned this the last chapter. And that force is proportional to a spring constant k. So this is Hooke's law, remember? F equals kx, that was Hooke's law. Okay? Well, the average force then exerted on it is just going to be that divided by 2. Okay? So 1/2 kx is our average force exerted on the spring. Since the average force is 1/2 kx, then the work done in changing the length of that spring is 1/2 kx squared. Okay, so this is our work for elastic potential energy. So we now have 3. We have a work for kinetic energy, we have a work for potential energy, gravitational potential energy, and we have a work for elastic potential energy. Okay, 1/2 kx squared. And it's x squared because it's the force, 1/2 kx, times the distance that it moved, which is also x. So it's x squared. Okay, so everybody have those down? So here's an example. Spring with a spring constant of 120 newtons per meter is compressed a distance of 2.3 centimeters. How much potential energy is stored in the spring? So we're just going to plug into 1/2 kx squared. That's the potential energy or the work. So 1/2 kx squared means 1/2 times 120 newtons per meter times 0.023 meters. And then don't forget to square that. Okay, on a test or on a quiz or something like that, that's where you can make a very easy, careless mistake is you just plug it in and think, oh, okay, I gotta go. Don't forget to square it. Okay. Got it? So conservation of energy. Energy comes in lots of different forms. We've talked about gravitational, we've talked about potential, kinetic, all that. Actually, we're going to stop there because that gets into 6.3, and we're not going to do 6.3 right now. So, all right.